Hi, Jake from Real Robots here. Today we'll be continuing making our Arduino custom controller software. In the previous episode, we wrote this software to send mouse and keyboard presses from our Arduino to the computer. In this episode, we're going to take that code and make it more extensible. We're going to make some classes, use some object-oriented programming so that we can make our own library and make this a lot more useful in the future, not just for this project. Alright, now continuing from where we left off. Right now we have a single button producing a mouse press. We've also practiced doing keyboard presses. If you did want to go ahead and just add a few buttons, all you would have to do is set the pin mode for that. We've actually got one on pin 16. Change the button state from a single integer to an array of 2. Now I don't have to actually initialize these. They're automatically initialized for each integer to be 0, which is what I like. And for each of these, what we would do is just put it in a loop for int I equals 0, I is less than 2, I plus plus. And you just, oops. Put your values in there. Now this one, what we would also have to do is just go int button pins, and it's 10 and 10 and 16. So button pins I, and then same thing here. Well, let's put the whole thing in a loop. So I just pressed Shift Alt F, which just reformats. We're in a bit of a habit of doing that. So if you do see everything go sort of suddenly become nicely formatted, that's what's happened. So button state I, in fact, all of these are just going to be I's. Now here's where it gets tricky, because if I wanted this button to do a mouse, it's easy enough. If they both wanted to be mouse, I could just go int output value, and let's say we had a left mouse button and a right mouse button. That would be pretty easy to do. So the first button, if it was button 0, it would do that. Sorry, if it was button 0, it would be left click, and if it was button 1, it would be a right click. Let's test that out. So I'm going to go Control Alt U to upload. All right, now let's see what happens. I'm just going to put this over here. And so pressing let me turn this over, see a bit better. Press the button. Let me press the button and drag it down. You can see that's a left mouse. If I double click, and a right mouse button. So you can see that's not too tricky to do. But every time I add a new button, I've got to add a line here, I've got to add another thing up here, I've got to add stuff down here, and it gets out of hand. So this is where we want to get away from the basics and do object-oriented programming. So let's, I'm just going to mass Control Z, go back to where we started. So we're back where we started today. We just have the simple button set up, a single button, and we're going to create a library. So I'm going to make a new file called controller.h. If you're using the Arduino IDE, you can't just make a new tab. You'll have to actually go to your Windows Explorer or your File Explorer and make a new file called controller.h. If you just press a new tab and make a controller file, it'll be a .ino, which is treated a little bit differently. And what we do with a .h file is we can go include controller.h, and I'm sure I spelled that wrong, controller.h. And what it'll do is when it gets to here, it'll go and grab all this code and stick it there for us. So we can start getting rid of all this stuff and shifting it over here. Because that's what we want. We want in our normal Arduino controller.ino file to be pretty basic and all the real stuff to happen over here in the library. So if we ever want to add this file to something else, we're doing another project, it'll be easier to bring in. And what we're going to do is make a class, a controller class, which will represent our whole controller. So an Arduino class, you've got to have the semicolon at the end. We need to mark public and private for our different variables. Actually, I'm not going to do any private variables, so let's keep it just public for now. You have your constructor. And you usually won't do much in the constructor, but it's good to put a little init here, and that's usually where you'll set things up, because it's a bit weird how Arduino does the constructors. You can't really control when it happens, because I'm going to go and up here, go controller con, and that actually calls my constructor. And because it's before we start the setup, before we start the loop, you don't have much control over it. So usually don't do too much in the constructor except for setting some starting variables. And then once you get down here, you'll go con.init. That's assuming you have anything you have to initialize, which we don't really at the moment. So let's leave it for now. And what the controller is going to have is a whole bunch of inputs. So it's going to have an array of inputs called inputs. And I need to tell it how many I'm going to have in the array. Let's just say 32. That's enough. And then I have to actually make this input class. Class input public. Whoops. I always like to put all this stuff in at the start, even if I'm not using it yet, just because otherwise I forget later. So input constructor and void init. And I'm just going to go Control Alt R and just verify it, because I tend to make spelling mistakes when I put in that much stuff at the same time. Beautiful, no mistakes. So I'm not sure if I said the input is actually going to be a button, a joystick, any sort of input. So the controller could have plenty of them. And what I want to do is when you create the controller, we're going to say controller.add input. And the reason I want it done over here rather than just hard coding it in here is because I want to be able to do it at a runtime. For one thing, it's just handy to be able to go add input, and add them all in one spot. A bit more customizable, but what I really want to be able to do later, I think I've mentioned before, is have this set up from a separate app, which will talk to this through serial. So a serial packet will come in that will tell it which inputs to make. But for now, we'll just do them in here. So what does an input need to have? First of all, well, it needs to have that pin number. So it needs to be pin 10. We're going to have to tell it what it actually does. So that would be the value that it sends, whether it's a key press of 1 or let's say a keyboard press of F. Now, if it just has that, it's not going to know if it's meant to be a key press. If you tried to put F into here, it doesn't know, a mouse doesn't know what to do with an F. So what we're going to have to actually do is have it know. So back over here, I'm going to make some variables, not variables, some keywords I should say. Let's say input type keyboard button. That'll be 0. And input type mouse button. So now what we can do is say, all right, so this input is on pin 10. That's the input it's putting in, and it's going to be an input of type keyboard button. And because all this stuff happens at the top here, before anything comes in here, it knows what it's doing. And then of course we have to just add this into here. So void add input, and it's going to be an integer of pin, and then an integer of input value, and an integer. Is that gone green? Have I used that before? Not sure why that's green. Let's just call it input val. Interesting. Not sure why that's gone green there, but let's leave it there for now. And finally, input type. Now, because we've just declared this array here like this, we don't know which one's empty, which one's not. In fact, none of them are empty. They all have a basic input in them. So what we're going to do is just go input count, inputs, input count, which will at the moment be 0. We're going to set its pin to pin. We're going to set its input value to input value, and its input type to input type. And is there anything else we need to do? I don't think so. Of course, we need to actually give it all these variables. In pin, in input val, in input type. Now that pin number, we need to initialize it. So let's, at the end of all that, just go inputs, input count, and let's call init. And in the init, it'll just do its own little, do a setup, which is set that pin. So the pin will be pin mode, pin input pull up. Now that's another thing which may be different sometimes, but we'll leave that for now, because if you created a device that had its own pull up or pull down resistors, you wouldn't want to use that. You would also not need this if it's potentiometer or anything like that. But let's just stick with buttons for now. All right, and now this loop has to happen in here. So we're actually going to grab all this stuff and have that happen here in the button. So I'm just pressing Shift-Alt-F, which formats this all beautifully for me. And we need button states. So int button state, int button state previous. That one, we already know that, that's the pin. And what's going to happen here, because now we actually know whether it'll be a mouse or a keyboard press, we just go if the input type equals input type keyboard button, then we're going to go keyboard.press. Let me just drag that across a bit so we can see a bit more happening over here. We don't really need this at the moment. Keyboard press, and it's going to be input val. Or else, if it's an input of type mouse button, it's going to be mouse press, and it'll still use the input val. So let's just grab that whole thing and copy it down here. And of course, it'll just be release instead of press. Still have the print line on button down, on button up. So now we just have to make sure this update is called. So what we're going to do is the controller is going to have an update as well. And it's just going to go a loop through all its inputs. Int I equals 0. I is less than the input count, so it's only going to go through the inputs we've added. It won't do all 32. And then I plus plus, and just inputs I update. And then over here, let's just do con.update, and that'll update our controller object here. And just for fun, why don't we add the second button now? So my second button is on pin 16, and let's just make that do a G. No, let's make it a mouse. So 2 and input of mouse button type. So we should have the red button will give us an F, and the green button will give us a right mouse click. Let's see if we're, ooh, I've just noticed here I have not put my parenthesis on that one there. Let's upload it and see if I forgot to do anything else. Actually, no, I'm going to do one thing. Before I do it, I'm just going to comment out these. The reason I'm doing that is because if I have done something wrong and it spams through millions of key presses at once, it's a real pain in the bum. And you try re-uploading a blank firmware when it's sending G's and F's and whatever junk at you. So we'll still have the on button down, on button up, so we can just make sure the buttons are working properly first. So Control-Alt-U to upload the code. And there we go. What have I done wrong? Input value, input type. Looks like I forgot a semicolon somewhere on line 15. Yep, there we go. All right, let's try again. Control-Alt-U. And what have I done this time? Line 78. Oh, I put a semicolon there instead of a comma. I'm sure you guys all saw me do that and have been screaming at me this whole time. I apologize. I just realized I did that with that in the way. What I had was right here, a semicolon there instead of a comma. And it uploaded fine. So let's bring that video back. Put the cursor over here. So it should be when I push this button, we'll get an F. I tell a lie. When I push that button, we should get a serial message saying on button down. And I don't get that either. All right, let's walk our way through that quickly. First of all, I just realized I've got to get rid of that video for now. I've got that pin mode there, which we don't need anymore. That's superfluous. So what I'm going to do is just put a serial print line of the button state here and just make sure we're getting button presses through. Let's see how far we're actually getting. Before I do that, I'm going to go serial.print. Let's put the pin number so we can recognize which one we're using, which input it is that we're using. All right, let's see what we get from that. We're uploaded, the port's open. Let's see what happens. Ah, the extension's crashed. We're lots of fun today. All right, connect the serial again. And let's see what we get. Still getting nothing. But we're not even getting this message, so we're not getting this update called. And I've just realized what I've done. I've never incremented the input count. What a noob. Yes, and we can see we're getting some data through now and push the button. Yes. So what I'd done when we were putting in a new input, we weren't incrementing the input count. And so then when we were running the update, it was running from 0 to 0, so not doing anything. So let's get rid of these test print lines and just do an upload again. And yeah, on button down, on button up. That's working, so nothing's going weird, so let's go ahead and allow the key presses. I'm 100% sure that will work, but I've been that sure before, so let's test it anyway. So this first button should give me an F. Yeah, if I hold it down, F until I let go. And with the mouse cursor here, I'm going to press the green button, which will give me a right click. Excellent. All right, so let's leave it there for now. We don't need these actually. Let's see what else we don't need. So let's take the keyboard begin and mouse begin and stick that in there. That's what I wanted the init for. And so now you can see when you start a new file, all you have to do is include that controller.h, just create the controller, initialize it, give it whatever controls you've got. So if you had 20 controls, you could go ahead and put them all in now. So long as they're just keyboard and mouse buttons, we haven't put mouse movements and things like that yet. And just call your controller update. And that's it. You've got a code that for the next controller you make, you can whip it out again and use it whenever you like. That's what we should be looking for when we make code, is reusability. At least some of the time. Alright guys, I'll leave that there for now because this is running a bit longer than what I thought already with you guys watching me go on that bug hunt. I'll leave it there. So thanks for watching and I'll see you in the next video.